a rod. To find the moment of inertia of a rod, so we'll find the moment of inertia for a rod. Moment of inertia for a rod. Before finding the moment of inertia, the mass distribution and position of the axis is very dependent parameters for finding the moment of inertia. So before finding the moment of inertia, we should know the position of the axis and the alignment of the body also, that is mass distribution. So there is a rod of mass m and length L. So length of the rod is L, and mass of the rod is m. And if the axis is passing through the center of the rod or middle of the rod, then how we will find the moment of inertia of this rod? So this dotted line represent the axis of rotation, means the axis by which the object is rotating, object or rod is rotating. So as we know, as we see that the axis is passing from the middle of the rod, so this distance will be half length of the rod, that means L by 2, and this distance will be half length of the rod, L by 2. If we set this position as origin, then the end position, the right hand end position of the rod will be, or its coordinate will be L by 2, 0, and its left hand position will be minus L by 2, 0. Now we will find the moment of inertia of this rod. But how? First we will write the equation of moment of inertia. So I equal to what? I equal to r square dm. First we write this. But now what is dm? What is the meaning of this dm? So dm, for finding dm, we will take a small slab of thickness dr at a distance r from the axis. So thickness of this small slab is dr and its distance from axis is r. Okay, so dm equal to what? Dm equal to mass of unit length multiplied by what? Thickness of the element. Thickness of the element. Now, but what is the mass of unit length? So total length of the rod is L and total mass of the rod is M. So mass of unit length will be equal to mass of unit length will be equal to what? Equal to M divided by L. That is the mass of unit length. And thickness of this rod will be is dr. So dm, so mass of this element dm will be equal to mass of unit length m divided by L into thickness of that element dr. Now in this equation, this is our equation number 1 and this is equation number 2. Now we will substitute the value of dm from equation number 2 to equation number 1. For doing this, what we'll do, we'll take I equal to integration of r square dm. That is equal to integration of r square dm. Dm means what? As you see, dm equal to m by l into dr. So dm will be equal to m divided by l into dr. But now we have to put the limits of this integration. So limit of this integration is, that is the left hand side. So our left hand side will becomes the lower limit and our right hand side becomes the upper limit. So our left hand side is minus l by 2 and the right hand side is l by 2. So our lower limit becomes minus l by 2 and upper limit will become only l by 2. So our integration becomes for carrying this integration, we will take outside of the integral we will take the constant outside of the integration. So what is the constant term here? The constant term here is m divided by l, and apart from the constant term there is another remaining thing is variable. So variable parameters are r square dr, and its limit is what? And its limit is from minus l by 2 to plus l by 2. So that will be equal to m divided by l into r square dr. Now from the standard integral results, integration of r square dr will be equal to r cube divided by 3, and its limits is minus l by 2 to plus l by 2. Now, so the moment of inertia, I becomes how much? I becomes m by l, m divided by l, and there is 3 in the denominator. So m divided by 3l into l by 2, because l by 2 is the upper limit, whole cube, minus l by 2 whole cube. So I becomes again m divided by 3l into l by 2 whole cube equal to l cube divided by 8 minus this minus and minus becomes plus, so that will be l cube divided by 8 plus l cube divided by 8. So totally ultimately this becomes m divided by 3l into l cube divided by 4. Now this power 3 will cancel by this l. So moment of inertia becomes what? So moment of inertia becomes I equal to m l square divided by 12. So this is the moment of inertia for a rod when axis of rotation is passing through the middle of the rod. So this is the moment of inertia. This is the moment of inertia. Moment of inertia for a rod when axis is passing through the center or the middle of the rod, passing through the middle of the rod, and also perpendicular to the length of the rod, to the length of the rod. Now we'll see what will be the moment of inertia for a rod when the axis of rotation is passing through one side of the rod. So our second question is, find the moment of inertia. Find the moment of inertia. Moment of inertia. Find the moment of inertia of a rod when the axis of rotation, rotation passing through one end of the rod, passing through one end of the rod. For this situation, first what we'll do, we'll draw the diagram. So let this is the axis of rotation. So dotted line represents the axis of rotation. Now this is the rod, position of the rod. Its length is L and its mass equal to M. As this is the axis of rotation. Now what we'll take? We'll take the small element of thickness dr at the distance r from the axis. Now, what is and mass of this small element is what? Mass of this small element is dm. So what is dm from the previous method? We know dm equal to what? Dm equal to total mass divided by total length, that is unit mass. This is nothing but mass of unit length. This is mass of unit length. Multiplied by length of a small element. So what is length of a small element? This is nothing but dr. So this is length of a small element. Length of a small element. Length of a small element. But what is the definition of moment of inertia? From the definition of moment of inertia, I equal to what? I equal to integration of r square dm. So, and its limit is from where? If we set this axis as the origin, so it is 0, and its end is coordinate of this. Its end is L, 0, and it is 0, 0. So our limit will becomes from left to right. What is the left limit? Left limit is 0 and right limit is L. So our limit of the integration becomes 0 to L. So we'll proceed the integration. If we proceed the integration, that will be 0 to L. This is r square, and what is dm? And dm is m divided by L into dr. So it becomes m divided by L into integration r square dr, and its limit becomes 0 to L. So this will becomes m divided by L, and integration of r square dr equal to r cube divided by 3, and its limit is from 0 to L. If we put the limits, then m divided by L, m divided by 3L, because 3 is constant, it will come outside, and it becomes, first we put the upper limit. What is upper limit? Our upper limit is L, so L cube minus what is lower limit? Minus lower limit, 0 cube. So our moment of inertia of this type of rod will become I equal to m divided by 3L. into L cube. Now this L cancels the power. So after cancellation, I becomes 1/3 in L square. So this is the moment of inertia of a rod when the axis is passing through one end of the rod. So this is the moment of inertia of the rod. This is the moment of inertia, moment of inertia, inertia of a rod when axis is passing through one end of the rod, end of the rod. Now we take the third situation. Our third situation is when the axis of the rotation is axis of the rod. Our third